There's a claim.
Yeah, there is a claim.
Oh, excellent. Let's hear it.
Did you anybody miss Globebusters, or did we all watch it last night?
Oh, I saw it.
I know you were going to talk about this, Riley.
Yeah, I knew you were going to talk about it.
Okay,
too,
I didn't, so you'll have to fill me in.
Okay. So on Globebusters last night, Bob made some assertions without any evidence whatsoever other than his hunch. Now, to be fair, he is and was spitballing for the most part. However, he dogmatically asserts for the other part where he's not spitballing that there is definitely a force here. There's definitely a force in play. Now, we're going to have to go through this because there's clearly disagreements with this is the beauty of why flat earth is not a cult. So for anybody that thinks that we are culty, then I'm sorry, but this is good evidence that proves that this is not culty, because this is a disagreement on topic, and it's going to be done properly, because Bob can be a little bit sensitive about people that disagree with him. So I'm going to do it as nice as possible so that I don't cause any rifts. Okay?
How dare you? Bob is about as conciliatory as it is when it comes to things like this.
Whoa, say that again.
But how dare you? Bob is completely amiable. I don't know how you can ever suggest such a thing.
Sure, but I don't want to. What I'm trying to present to the audience here. Bear in mind, I'm going to talk to mainly our audience rather than the ballers. I'm going to do it like the nicest way possible so that it's not any kind of like friction. It's purely down to what's said and what he's asserting. So I need to do a sound check first. Just let me know that you can hear this, Nathan.
So, hello.
Yes, we heard that, Nate. We heard that, Tony. Yeah.
I heard so. Hello.
Hello.
Oh, that was Arwin. Hey, Arwin.
It's me, Arwin.
I thought, why is Arwin on Globebusters? That was a bit strange. Let's try that again. Let's just try that again, Anthony.
No, that was just my Jazzaconda voice.
Of course, when we're doing a sound check, it would be Arwin. Best moment to talk.
Right, so I'm gonna do a sound check. Just let me hint. His first word is so.
So,
did you hear that?
Yes.
Yeah.
Okay. So what I'm going to do, I'm going to play some of these clips, right? And I'm going to, I've got 3 main clips to play. This is the biggest chunk. I'll segregate this, or I'll split it up into bits so that we can chat about it. But listen to what he says. Now, I'm going to take ownership of this. He may or may not have aimed this at me. I don't think he did aim it at me, because if he did, he got the assertion wrong. But I'm going to act as though it's aimed at me, because I do push this view, because I want to see proof that there is a force claim.
Riley, you're falling into the same trap that you once set. You're doing Adele.
And you're doing a rumpus.
I'm going to get some popcorn and go on mute.
Yeah, Owen, would you do me a favour as well? Would you go and get some popcorn too?
Yeah, it's just save it till after the end, because otherwise if you interrupt the recording...
No, I'll not interrupt.
It's just going to get really disjointed. It's one thing for us because we can react live, but the recording can't, so...
So I'm going to start with, I'm going to split this chunk up, because this is a few minutes, this one. So I'm going to try and skip through the bits that we don't need, but the gist of it is that he's demanding that there's a force. He spitballs about what's causing it. That bit's fine, but it's the demanding of the force bit that I want to focus on.
Sorry,
so let's go.
I'm just really confused. I'm sorry to interrupt before you've even started, but this started off with you saying, was this an answer to axial rotation or gravity?
Gravity.
Oh, so, okay. Any scientific evidence of gravity, this is what we've got. Great. Sorry, Anthony. Go ahead.
This is a claim for gravity. Okay.
There's something that I want to talk about here a little bit, because there are certain people in this community, and many of you know who he is. I'm not going to mention his name, but he seems to think that the only thing, and a lot of people think this, and I just want to kind of chime in on my 2 cents about this, about gravity forces and stuff like that. But this particular person seems to think that the only thing that matters is density and buoyancy. All right. Well, that's great. And I'm certainly not going to say that density and buoyancy are not a factor, because they absolutely are, when we're talking about what we're perceiving as gravity. Now, as I have said many times before and started saying, I don't know, I think damn near from the very first episode of Globebusters, 4 years ago, that, the density and buoyancy argument works great, but there is still something that is determining up from down.
Now, the minute he said this, I realized that this is... Now, I don't know whether he's aiming this at me or not, because I do push this view, but he's not got the assertion right. I don't say that density and buoyancy is it. That isn't the assertion. The phrase that I use is relative density, because basically this does explain everything. It explains the acceleration. It explains the direction, the so-called direction. But he says that there is still something that is defining up from down. Well, the thing that defines up from down, if I pull up my thing here, here we go. So this is a definition for vector. Now, Bob knows this, but I don't think I think he's forgotten it. If you're a vector in maths, right, a quantity having direction as well as magnitude, especially as determining the position of one or more point in space relative to another. What was that, Nathan?
I think that was from your own equipment. You're feeding back or something.
Oh, it might be me feeding back because I'll have to knock that off more. I'll have to keep turning that back on when I play it. Anyway, so the point is, he's got this this definition for vector. He seems to be forgetting this, right? Look at the key phrase is it's a quantity having direction as well as magnitude, especially as this is the bit, especially as determining the position of one point in space relative to another. Now the thing is, we're all familiar with the density tower, right? So I'll just flick this on hopefully quickly. Where is it? Density layer. Shut my door, hang on. Shut up. So if we consider the definition for vector, or a definition for vector, let's see if I can get this on screen at the same time. We have I thought it was going so lovely. Right, there we go. So all of these layers can be given numerical values, right? And they're all relative to each other. They don't mix, they're immiscible, but because they don't mix, they've got to take up a position that's not the same position as somewhere else. And the thing that orders it is the density itself. Now, it doesn't matter what they're called. It doesn't matter whether they're numbers, letters, types. It doesn't matter. They can be called horse hooves. Who cares? But they're all relative to each other. Now, the bit that Bob seems to be forgetting is the vector is determined by the position of one liquid in space relative to another. So you have, in this instance, you have the water and you have the dish soap. And relative to each other, a vector is created by virtue of the two things like next to each other. The vector is created by these two things. So what about the acceleration? Well, do you remember when we did, do you remember when Nick from Phuket Word did his, where's the gravity gone? Let's go to it, because this is a really good video. Show me the gravity. Where's the gravity gone? Where did gravity go? Hopefully I'll find this really quick. Where did gravity go? It's in my history because I watched it earlier on. It's fabulous. Go on, quick.
Shout out to Gary Awesome.
Oh, where is this video? There we go.
To have us be...
Shout out retracted.
Why?
So in this video,
wait, I know why.
He's got two mediums that look the same, but they're not the same. And one of them is just tap water, and the other one's been altered with salt water. And what he does is he shows that when you put the egg in one of them, the egg sinks. But when you put the egg in the other one, it floats. So we know the density of the egg is constant. But we can tell by virtue of what the egg's doing that the medium are different. Both mediums are not the same because the egg's not doing the same thing. So we know relative to each medium that the egg is either sinking because it's more dense or floating because it's less dense. But what he then does, which is a stroke of genius, and this is the bit that really Bob needs to play with himself, because that sounded terrible. Bob needs to redo this himself, because this basically changes everything for him. It should do anyway. What he does is he adds a little bit of the more dense water to the less dense solution, changes the density of the medium, and then displaces the egg. That's the key point. It displaces the egg. Nothing else was changed. Now, we know that in scientific method, that the independent variable is the thing that you change in your test that's going to denote what is the cause and the effect. It's going to be the cause. So if we're to accept that the cause in a scientific experiment is the independent variable and the thing that you manipulate, he's just literally created a movement without having a force. Now, Bob has on screen in his video, whilst he's talking, he has the definition of force. Now, that egg, he's caused that egg to change its position by changing the medium that's around it. That vector, that creates the vector, and that creates displacement. And that is perfectly in line with what it says for the definition for vector, because it's determining the position of one point in space relative to another. So the egg would be one point, and then relative to the other, it's the other. And the cause was changing the medium. We've done that ourselves. So if we accept the independent variable as the cause, then the cause was changing the medium by adding a little bit of more dense or less dense water to it. However, when Bob's talking, let's go back to this. When he gets to a certain point, he has on screen. He actually has on screen the definition of force, and what the bit he concentrates on is a force can cause an object with mass to change its velocity, and he literally says the words: if you've got an acceleration, you've got a force. You can't get around it. It's always going to be the case, and that's literally what he says. But he ignores the word interaction. He misses it. Maybe probably accidentally. He maybe skims over it, but it requires an interaction. So if you go for another definition of force, it's just to see whether or not there's consistency. There's another just type in force definition: strength or energy as an attribute.
Hold on, it's a formological fallacy, isn't it?
Go on.
Well, if he says if there's acceleration, then there must be a force. That's true. But does that mean that gravity must be acceleration caused because it is apparently there? That sounds like a formological fallacy, right?
It's not true, because we got the egg to displace or change its position or accelerate, and we didn't apply a force. But the key is look at the word in it. The word he misses is the word interaction. And then if you go for a secondary definition, is just to see that we're not cherry picking or being unfair. Another definition states that it has to be a physical action or movement. So the problem we have is strength or energy as an attribute of physical action. So there's got to be a physical action, but then it does say or movement. So that's where it gets a little bit weird, because that allows F equals ma to come into it. But you can look up all the definitions of force that you want, and it's a bit like looking up definitions for gravity. They all kind of say around about the same kind of thing, and it gets a little bit confusing. But the point is, if there's a force, I'm going to assert that there has to be some element of physical action, because what's creating the force? Now, that's what Bob argues about, is spitballing for whether it's electrostatic or whatever. And I'm not really bothered about whether or not it doesn't matter what he's spitballing. The point is there a force there in the first place? Forget about what causes it. Is there a force? I'm going to say there's no force, and we don't need a force because we can demonstrate it without applying any force. So what would be interesting here is if Bob got this same test and he got a jug and he got the egg into the point where it's neutrally buoyant in the middle. And then if he took 50 meters out, oh, by the way, I don't think that sound played through then, did it? Oh, no, I didn't play sound. It's okay. If he took 50 milliliters of this jug, the medium that's in the jug, take 50 mils out of it, and then replace that same 50 mils with salt-saturated solution of the same volume. So salt-saturated 50 mils, put it back in. What should happen firstly, he's going to disprove gravity as a thing, right? Because what will happen is the density of the salt solution will drop to the bottom, and it'll force the egg to rise up, because that'll add to the vector. That'll create movement, right? But if we know the salt solution is most dense, and it should pool at the bottom, according to what we're told, but that would add to the weight of the mass of the earth below it, and it should attract the egg towards it. But we know it's going to push it away. So on the one hand, he's going to literally add the mass here, should pull the egg down, but we know it'll displace the egg, and the egg will rise. So that'll prove that gravity doesn't exist. That's the first point. But the second point for Bob to consider is, if he does put the salt solution in and it pools at the bottom, then he's just altered the density of the medium by removing 50 mil and then putting it back in again, the same water but saturated. So he's got to explain, why is there a displacement when there's no force? Because we can explain with vector, because we know the vector, two mediums relative to each other. He's got to explain how there's a movement if there's no force, because there is no force. But he'll say, well, it's moving. There's the fact that you've got an accelerating mass, F equals ma, right? No, because we manipulate the cause was changing the medium. The cause was not adding a force. So it gets semantic with the definition of words, the meaning of words. But I want to go back to these last two bits here because I didn't really play all of that. But listen to what he says.
No sound. No sound.
Ooh, okay. So it's going to be that. It's one of them two.
While he's doing that, hey Nathan, I don't know if you're aware of it. I sent you a message, but the link in the description is the Discord server, not the Hangout.
Okay, thank you.
Anyway, that's all I'm going to say about this. But the bottom line is that gravity, whatever it is indeed a force, right? There has to be a force that is applied that causes this acceleration, right? You cannot have acceleration without a force, right? So density and buoyancy by themselves are not going to cut it. It just, there has to be something there that sets that initial bias potential for up. I hope people understand.
For the love of God, you just caused a load of feedback. Could you not just stay on mute while it played?
It just, there has to be something there that sets that initial bias potential for up from down. And I hope people understand that. But, you know, those who go on and say, well, we don't need gravity because everything works fine with buoyancy and density. I'm sorry, it does not, because you cannot explain the acceleration that is taking place when you drop things from a very high place. Any comments on this, guys?
So he's talking about the acceleration at very high points, right? Well, in a very high tower, if you're going to drop an egg, if you do it it doesn't matter. Your egg has got a density that is greater than the medium in which it sits. That displacement we can replicate without dropping an egg. Now, he talks about when he walks up to the top of a tower, and some people argue that that's to do with him putting the energy into it, and he rejects that. Okay, but the fact is, when we get this egg in this neutral buoyant position, then we can make that egg displace just by changing the medium it's in. No force required. Now, if you're going to argue that F equals ma, therefore you've got an accelerating mass, therefore you must have a force. Again, this goes back to scientific method, because we do know that the presumed cause is the thing that we manipulate in the experiment, and we've manipulated the density around the egg. We did not add a force. Now, if you're going to claim that there was a force added because you've got an accelerating mass, I'm going to say, well, that's in addition to the density that we've just changed. So let's see the evidence for the force. And then you have to go back to the definition of force. And then basically he'll argue movement and I'll say physical action. But the reality is there isn't really a force there, is there? I don't think anybody would argue that there really is a force unless you're pro-gravity. Now, at the end of the day, the bottom line comes back to this last point that he says here. I'll play this bit and then we're done.
Somebody made the comment in the chat that if you lift something up and drop it, you're the force. No, I disagree with that. You are not the force. The force is what's causing the acceleration once you do let go of that object. Sure, I can take something up to the top of a building, and that's me all the way, taking it up there and letting it go. But something else is acting upon it for it to accelerate beyond the zero velocity when it leaves my hand to when it hits the ground. Now,
Now, this is where I can wrap this up now, because, again, if we go back to this picture, where's it gone? There. Because the egg's in neutral buoyancy, right? It sits in the middle. He said that if you take it up to the top of a building, right? Well, let's do it the opposite way to make the point. If we pull this egg out of its state of equilibrium, its rest, its comfortable position, we know the egg is going to go back to its point of comfort. It's equalized. It's going to go back to equilibrium. What we're doing when we move something up or down, we are moving it further away from its point of equilibrium. So when you take an egg up to the top of a building, or in this case, we pull the egg back down again and let go of it, it's going to rebalance itself out. And we know the cause of it is relative density. So Bob's right on the one hand when he says density and buoyancy doesn't go far enough. But he's wrong on the other hand when he says you need to have a force. There needs to be a force, because you don't need to have a force. If there's a force in this, evidence please. But what we can demonstrate is relative density. We can demonstrate the vector is caused by the relative densities. We can make them displace because we do it. We are the cause. That's what the scientific method states, and that's where the evidence points. But what Bob should do, see, this has got like 70, whatever this unit is, 70, I don't know if it's fluid ounces, 70 fluid ounces. If he took 10 fluid ounces out of this jug, replaced it with saturated salt solution of the same volume, and then put that back in so the water level went back up there, that egg would be pushed upwards. But the more dense mass should be down here at the bottom, because we know that's what will happen. And then that should add to the Earth's mass. So the egg should be attracted towards it. You disprove gravity immediately. But Bob would need to explain why the egg would displace upwards when he changes 10 fluid ounces of water and replaced it with saturated salt solution, because he is causing that by changing the medium. He's doing it. Where's the force? If you're going to claim there's a force, demonstrate said force, because we can demonstrate the medium. Anybody got any views?
Yes.
Sorry, Arwin, go on.
Yeah, thanks for rambling on like that. Jesus, that's like 2 years all over again. Okay, yeah, there is a force. It's part of the relative density. It is part of the mass. It is what is actually varied in the supposed gravity test, right? The mass. It has force that inherently appears when a disequilibrium point is reached. It happens. That's the force. There is definitely a force causing the displacement, and it is inherent to the density of things. The density offset is what causes the displacement, an acceleration, and that is a force. There is a force, Riley. It's just not a force field applying to all things, and that is what they presume.
Arwin, my question is, where is that force before the medium around that egg is changed? What is the force doing? Or does it have to be?
It's in an equilibrium.
Right.
It's not
So then when they change the medium, when they add or take away the salt, the egg moves, right?
Yeah,
so
and
what?
as
So
Bob
that
suggests, when there is motion, when there is displacement, there is a force. That is the force is causing the displacement. It's just simply inherent to matter. That it has
so
that.
You're saying the force doesn't appear or affect the object until the medium is changed?
Right, until it becomes in this equilibrium state.
So then how can we ever find out what the force is if all we're doing is changing the medium?
We can never. We can just determine that there is force, and we can directly relate it to the relative density theory and not presume that it is some kind of a field that penetrates everything and pushes everything down. That's not the case. It's simply a force that springs forth. When matter is in a relative density disequilibrium state and it has maneuverability, then force appears into being in that thing and displaces it until the equilibrium point within the relative density spectrum has been found, has been achieved. I'm done now.
I mean, it does make sense, but at the same time, I don't see changing just the medium proves a force. I mean, maybe it's just me. I don't know.
Okay, can I summarize
What
this? Go ahead, Paul. Go ahead.
Force at an equilibrium does not exert any motion. In response to chat.
What if we're kind of looking at this in a different way, or maybe we're looking at it wrong? Like when you pull the balloon down, in a way, you're kind of adding energy or kinetic energy to the balloon. Then in a sense, the energy is released. And so, like when you're pouring the water into, or that solution into the container, you're actually adding some level of kinetic energy because of I don't know if you know where I'm going with this, but it's not a force. It's just you're applying energy to it. Because I looked up the definition of energy, and one of the definition, here, I'll share it so you can see what I'm talking about. I could be way off base. I'm just trying to think outside the box here. Do you see my screen now?
Yeah, we got you up. Hey, Anon, how you doing?
So,
go ahead, Paul.
What is energy explained? You know, obviously one of the explanation for energy is motion or kinetic energy. Do you see what I'm going? So instead of we're thinking about a force, but it finds equilibrium, and that means that there's potential energy there, but there's no kinetic energy. But once you apply anything to that, whether me lifting it up, I'm actually applying kinetic energy to that object. I'm just I'm throwing out ideas. You guys can help me.
No, you're right, Paul. Is anybody going to, before I summarise it, I just want anybody else to chuck their 2 pennyworth in. But you're right. Anybody? Right. Up and down are not objective directions. They are relative. What are they relative to? Well, shock horror, the medium. Generally speaking, unless someone can tell me between now and when I finish this statement with one of the pictures on screen, generally things are in equilibrium, or at the very least trying to find equilibrium and very quickly find it. Now, all of the examples I heard were picking things up and dropping them off buildings, quickly to then disregard the fact that they've been picked up and taken to the top of a building. So Anthony's example I can better. Sorry, Anthony. There's a lake with buildings in it in Wales. It's literally an old town that they've flooded. It's now a massive, great big lake. So there's buildings in there. Now you could go in your scuba kit with your egg, go to the top of a building, hold it out, let the egg go, and it would go up. Well, you've climbed to the top of a building, let an egg go, and it's gone up. Well, why? Well, because it's not an objective direction. It's relative to the medium. So that's the first point. The second point is Paul's just summarised it really. Yeah, you're putting energy in. Simple as that. Unless you can show me where there's a disequilibrium, generally speaking, I don't see eggs falling to the ground as a natural tendency. Generally, as a natural tendency, things are in equilibrium until you force them out of it. Any other scientific or otherwise evidence of gravity?
Nope.
Perfect. Any evidence of the distance to the sun?
No.
Nope. I was going to say, a pretty good argument you could say to the whole egg dropping theory is say if you had a ball full of atmosphere or air in your hand and you let it go into the atmosphere, which is the same density, what's it going to do? It's just going to stay exactly where you left it. So it's density, isn't it? So the egg, obviously it's denser, it's going to fall. Is that what you're getting on? Is that what you mean?
Not really. Show me this falling egg. Where do we generally observe things falling? Where does this naturally occur? You could say rain, and I could say condensation or humidity rather. There you go. It's not going down, is it? It's going up. Oh right, that's not.
Yeah.
But other than that, you show me where there's stuff tending to fall towards the ground.
How about leaves and branches and?
Oh right. So I'll go back to the ocean bed. Something's growing on the ocean floor, a leaf, so to speak. It breaks off. Does it go down or does it float to the top?
I'm not sure. That depends on its density.
It depends on the medium. So it's relative.
Also?
So we're not talking objective directions. We're talking relative directions.
Right. Well, it depends on both the medium and itself.
So we don't need to concern ourselves with attributing a force to a relative direction now, do we? That's absurd. You can argue about this all day if you like, Arwin. This is one of those things.
Comes into being. I'm not suggesting there is a gravity force field applying.
I know you are
triggered about force manifesting as soon as something is out of equilibrium.
Saying the same things that you've been saying for about 18 months.
No,
I'm at peace with
I'm
this.
not.
There is no need to attribute a force to a relative direction when it is relative.
Displacement is part of relative density theory, and it is the force that actually drives the motion, the displacement.
In which direction?
That's
this absolute direction
relevant.
of down that we have? Oh, we don't have one.
Towards its equilibrium. Very simple.
Towards equilibrium. That's not down then, is it?
I'm not claiming it is down.
Well, what are we talking about then? The force of what?
The force of the displacement.
Well, that's a force of displacement.
Something in motion. It can be when it's not in its equilibrium point.
you're talking in double Dutch. That's the displacement itself, isn't it? For some things they go down, others they go up.
So there is a force. But
Owen,
it's not
I've just said,
caused by
you might be triggered about this because you're just
I'm not triggered about anything,
Well, stop
Nathan.
talking
I'm
over me
simply
then.
discussing
Why are you talking
back.
over me then? I didn't interrupt while you said the same thing 6 times. I sat and patiently listened. Now I'm talking and you want to talk all over me. Yeah, we're not in any rush to assign a force to a relative direction. It's simply benign. It's not needed. There is no need. So when you say, well, there is a force, the force of it going to its equilibrium, well, which direction would that be? Oh, it doesn't have one. Yeah, that's the point here, isn't it? We're talking about the force of down, which we don't have.
Doesn't it go in a direction then?
What
Never?
direction? Relative to what? Relative
That's
to the
not the question.
Yeah,
A direction.
yeah, the directions relative to the bloody
direction
medium. That's
away
exactly
from
the
where it
question.
was.
That is the question because
Does it move away from
it doesn't
from the point
have
where it
an
was?
absolute direction. That's the point.
I'm not asking about a direction. I'm just asking, is it moving away from where it was?
Yeah, that's what Anthony
Right.
covered right at the
Then there is
start.
displacement.
Yeah, so you can assign a vector, not an absolute down, and then give
I'm
that
not doing that.
Owen, why are you doing this?
Well, you're putting words in my mouth.
I'm
You
not. I'm
constantly
just
say down,
talking.
you down. I
I'm
didn't
just
say down.
talking. You don't like it. That's the problem here.
I don't like having words put in my mouth.
I'm not.
That's correct. I never said down, Nathan.
I don't care what you said.
Well, then don't tell me that I used that.
You have
because I don't-
decided to usurp this argument like it's against you, right? There was a whole presentation that you couldn't shut your mouth through. Now you think this is about you. You're not the centre of the universe, Arwin. This wasn't about you in the slightest, was it? You've made it about you.
Are we still here?
Yeah, Arwin just buggered off when it was pointed out that he's completely hijacked this point made about him. So, to summarise, yeah, there is no objective down. Sorry, down is not an objective direction. It's a relative direction. That's what we're talking about, relative density. So you can't just say this will go down, because it's not necessarily the case. Ah, for Jesus wept. Mind warped.
Yeah, sorry, I just muted. I'm very sorry.
Moving on. Hey, McDonnie for you. How you doing? Hear us? You're on mute, my friend.
Hello, hello.
Good to have you.
Hello.
Any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
No.
Nope.
Any evidence that you can have gas pressure without a container?
Well, Blue Marble Science Guy's done a response video recently. Have you seen it, Nathan?
I don't watch this garbage. Yeah, I get to see it here though, which is nice. What's his response?
Was that the one we're,
This is
is
the
that the one
same
we're talking
dude.
about the other day with the long tube going up the side of his chimney?
Right,
And he has butane gas?
that's the one.
Yeah, yeah.
He's done a response, and basically what he's saying is, but in your video of Ballbusters number 5, I think he was referencing, he said specifically that, well, John demanded that it was a sealed unit, and I've got an open unit, so therefore you can have gas pressure next to a vacuum container or gas pressure without a container. Now, what he's doing is he's swapping the point that John's making initially with the point that he makes secondary. John's point is first, how do you have gas pressure without a container? That establishes that you have to have a containment. Their argument is gravity causes the containment. Okay. We can demonstrate gas pressure in a container, but they can't demonstrate gravity to cause anything, because you have to ask them, well, what gravity are you referencing? Are you referencing Isaac Newton stuff that was superseded by Einstein stuff? Or are you referencing Einstein stuff? But either way, you still can't demonstrate gravity causing anything. But they all think that it's proven, and he thinks that we've got to disprove gravity because it's been proven that many times over, and it's accepted by everyone. But he switched the burden of proof against us. We're asking for the proof for gravity, and we're using the atmosphere because it's a strong argument to demonstrate that we can demonstrate pressure with containment, but you guys cannot demonstrate gravity with containment, and that's our point. But what he does is conflates that point against the idea that he had an open pipe. He conflates that point with his secondary point, which is that he had an open pipe. And when he had his open pipe, he was happy to tell us that it didn't really move much over 3 hours. And he quotes John for saying, if I come back to the sulfur hexafluoride after 3 or 4 hours, it'd all be gone. And he was dead pleased that he used 3 hours because he's directly referencing John. What he's not doing is he's not comparing the two tests, because the sulfur hexafluoride was demonstrated in the fish tank that's got a massive surface area and a shallow pool, with his pipe that's got a very tiny surface area and a massive depth to it. So you're not going to get much entropy out of the pipe. But because he's conflating the two terms, he's saying that John's moving the goalposts, and it's basically John's being dishonest by pointing out that it needs to be sealed when we live in an open environment. But he's missing the point that they're two separate points. They're not connected, but they are part of the topic. So basically, he says that, in short, he says that basically we can have gas pressure without containment in the atmosphere. That's it. And the second point is he says John demands that it's a sealed container, but we have an open system. So he's contrasting that point, but he doesn't realize that that kills it because entropy does apply. And if we have an open system, the pressure from Earth would bleed into space pretty much immediately. So he's just not getting it yet. I don't know whether he deserves a response video, but his video was quite well done, to be fair. He's obviously thought about it. He's just not realized that it kills his own argument in doing so. The guy's a bit struggled.
Not really. We're asking for the gas pressure without the tyre, right? This is akin to someone giving a tyre a slow puncture and going, look, I've come back 3 hours later and it's still got pressure inside it. It's like, no. We want to see the gas pressure without the container. So without the tyre, we want to see the gas pressure existing around the rim, if you like, of the wheel, but without the rubber bit around it, not with a slow puncher.
Which you can't do.
Yeah. He hasn't thought about his video response properly. He has done a video response. It is worth watching. And I did comment on it, but I don't think I'm going to respond to it because he hasn't realized the fallacious point that he's making actually works against him. But I'm sure John will be happy to have a go at that probably later on in the second show.
Well, I'm just happy to.
Like I said before, sorry.
No, you go ahead, Marvel.
Like I said before, my chair is so squeaky, so if it is going through my mic. Because he's using butane, which is 1 times heavier than air, plus the additives in there, because butane by itself has no smell, so they add additives so you know it's there, so you don't go and light a cigarette and blow yourself up. He's injecting that into the bottom of that pipe. That air that's already going to be in that pipe, just from natural occurrence, is going to basically act like a cap anyway, creating a closed pressured area, and its fastest escape is through that tube at the bottom that he attaches to the pressure monitor. So it's a flawed video. It's just proving a container of gas pressure.
Yeah, a gas gradient, and he's also failing to. The point I was making with the feedback is based on a large surface area. The entropy that comes from a very small, like what is it, a half inch pipe or whatever it was. The pressure, the entropy that comes as a result of that is minuscule. It would take you days for it to disperse, but it will disperse. But do it in a fish tank and let's see how that goes.
Yeah, in a fish tank it would go straight away. I mean, that tube, if he came back the next day, there'd be no pressure in there because it would have escaped eventually. But just because of the density of the two gases, it's basically capped. There's no difference between him putting capping the end of that pipe, or having the oxygen that was already in that, or the atmosphere that was already in that pipe, and then injecting the butane at the bottom, which he did. It's the same thing.
In no way, he's utilised relative density, demonstrated that you can have gas pressure gradients in a container, and that's it. The entropy effect might have been slowed by virtue, as you point out, the massive surface area of the pipe, the container he's using, when he utilises the pressure gradient, and as you put it, a more dense gas at the bottom. But entropy is still going to take effect, all the same. I mean, I said this, like you say, he's all chuffed that he's got 3 hours. It's like, well, that's an equivocation. We were talking about sulfur hexafluoride, again, a massively increased density of gas, man-made, I might add, that they put in a fish tank, as opposed to your equivalent of a slow puncture. You know, you've got this massive, great big tube with a huge surface area, an open top, and then a more dense gas at the bottom. So you're skewing it to make it seem like the tiny opening at the top is equivalent to a curved surface with no sides. Because in terms of what you're trying to create in terms of an equivalent, you're trying to create the equivalent of that fish tank without the sides and a curved bottom. Well, that's in no way equivalent to a tube with a massive surface area and a differing gas in terms of its density. You know, no, that's not the same. What we want to see is gas pressure without a container. I thought we made it really clear.
Yeah, he's claiming that his pipe is not containment. And I'm like, dude, pipe is the operative word. He doesn't get it. He thinks he gets it.
What's he measuring? What's on the needle, Anthony?
2 meters per the pipe.
What's on his needle that's attached to the container?
Containment.
No, the needle, what's it measuring?
Pressure.
So it's measuring PSI?
I'm not sure what unit it was in.
Anybody?
Probably would have been.
Let's assume it's measuring PSI. Yeah? Well, I mean, it might be bar. It doesn't matter what name we attribute to it. It's measuring the amount of pressure put on the walls of the container. That's what it's measuring. How much pressure is this butane putting onto the walls and onto this needle? Well, that's how you get the pressure measurement. It's measuring the force on the walls of the container. So we need to see that needle not attached to a container, even if you've got one that's managed to force a cap through relative density. Yeah? Well, what do do for you? Nice, well done for actually supporting our argument. But you've definitely got a container. That's what the needle's measuring. The pounds per square inch.
Globers would agree that it was a flawed experiment. You'd have to be dumb to not realise it.
Yeah. The needle's measuring the pounds per square inch of the walls of the container. Per square inch of what? The container.
The thing is, Nathan, we can forgive this guy because he's quite new for being a little bit green, dumb, stupid, whatever. I think the bigger point is Bob, the science guy, or Bob, the fallacy guy. His response video was the most dishonest response video I've ever seen. And he pushes it in that smarmy, patronizing way that I love it when Nathan does it the same way. He's mastered that. And that's what that Nathan, you should look on Bob the Science Guy as your mentor in terms of presenting, because that smarminess is the way to do it. It's really patronizing, condescending, and horrible. However, his points that he makes are literally contradictory, opposite, wrong, false. And he has to make this sound as though there's an argument there. And I was watching, I spent time responding to it, and I saw Dawn Treader in my chat. And Dawn Treader demonstrated that he was influenced by what Bob the fallacy guy said. Now, the problem is Bob the fallacy guy is talking and influencing people to make them think that you can have somehow a gas pressure next to a vacuum without containment, because he's lying about what's being said. Now, Dawn didn't notice that it was an intentional deception, a lie, a false fact. But if I did that, I would be hung, drawn, and quartered. So why is no one calling this out on the ball side?
Because they're all cheats and dishonest.
Yeah, I'd just like to add on to what you just said, Tony. Like this guy, even though he's green and he's probably new to the whole thing, you know, he should be applauded for actually going out and doing stuff like that. And I think we should highlight the fact that, you know, it's great that people go out and do these observations and do these things, and it's good. It's a good thing. So we should support it. and then, sit here and do what we do and debate it and pick up the flaws. So then people can actually move on and try and, different observations and then try and work things out. But yeah, the guy, in all honesty, he tried his best, but, it was flawed, obviously, but he should still be, at least told, good try.
Yeah,
I agree.
There's two ways of looking at it. One is to say, well, yeah, you've managed to get your name mentioned, and we've talked about blue marble science. Whether or not this shout out will get retracted, I don't know. But ultimately speaking, we're still ripping apart his assertions as being completely fallacious. So, would you take that as a compliment if it was your work that we were featuring and we were saying how stupid you were?
I think there's an onus on the ballers to correct this guy. I mean, there's been a few things recently that we've pointed out that people like conspiracy cats should be pointed out that if you don't manipulate your independent variable in a scientific test that you're claiming proves something, then you're not actually complying with scientific method. But conspiracy cats knows that he can't comply with scientific method when it comes to the shape of the earth because he'd be out of a job if he did. So I at least understand with him that he can't do that. However, the rumpus hasn't got a job to protect. The rumpus should be calling things like this out. Jeremy Gempanda should be calling things out, because if you don't comply with scientific method, it's pseudoscience, and there are errors being made on the ball Earth side, which of course they project onto us in some way, flip it against us, and then basically laugh at us in some way. End of the day, if it's not scientific method compliant, guys, it's pseudoscience, it's fake science, and the ballers are committing that crime. And it's like, why aren't ballers calling this out? They should be self-regulating themselves because they claim peer review process and all that. Where's the people on the baller side going to challenge or tell Blue Marble Science that he's not getting this right? Bob the Science Guy absolutely needs calling out by ballers because he's contradicting himself and he's misrepresenting, giving false statements of fact. Why is this being ignored? Come on, ballers. Are you not intellectually honest enough to call out your own? Have I been kicked?
No, I was just seeing if anybody reacted.
Where's Alan gone?
I think he dropped because I told him off because he got triggered when I pointed out there was no objective up and down.
I had to answer something happened in the background with the phone, but that was one of the points I wanted to address. I'll just mention it really quick while he's not here. Bob thinks that there's a relative up and down as well. Now, Nora also thinks that. Mark Doxey thinks that, and Arwin obviously still thinks that. Up and down are not the units in play here. When we're doing the eggs going up and down, the density and the buoyancy, it's not up and down. The units that we're talking about is dense over less dense, but we describe them as up and down in the same way that we say hot and cold. But it doesn't mean that hot and cold is like the valid units that we're using. Technically, it's hotter and colder, referencing the temperature in the same way that up and down is referencing the density or the less dense. So, yeah, I agree. There is no up and down. It's just a state relative to whatever your mediums are at the time. Einstein got this bit right. Relativity is relative to everything that you're talking about in the context of what you're talking about. And we can demonstrate it. So the idea that there's there's an up and down, no.
Good job. It's a good job John's not here. Hey, physics warrior.
Hey, Nathan. When I hear somebody say relative, I think of a third person.
You think of a what?
A third person.
I think of
a descendant relative, yeah. Kin.
Yes.
Yeah. So you're equivocating.
It's unfortunate.
Relativity is. Go ahead.
Well, Nathan, it's kind of interesting how you have to use relative to make this type of explanation. I mean, I get it. This up and down. Relative to what, you know what I mean, and for this particular model that we're supposed to be on.
Relative to the densities in question.
Yeah, even the density. Okay, so the relative density in question right now is due to the concept of up and down, and that's all they have is just up and down. I mean, if we're gonna identify this omnipresence of this force, whatever this G word is at, it should have this omnipresent all over, no up and down. Although I find it as a phenomena that we're going to use this particular force, this acceleration force or density is down. So I'm not happy with that because we have a relative in there.
Can I ask the question maybe along those lines? Maybe wouldn't it be a better question to say, or Like, why do denser things move towards the ground or towards the earth or whatever you want to term it, and less dense things move away from the earth towards the sky?
Yeah, you're referencing what you should be referencing is the mediums that they're all relative to. So, for example, the egg that's in that neutral buoyancy position, it isn't moving towards either earth or sky. It's sat in its neutral buoyant position because its density is equal to the medium in which it's in. But if you then say, oh, look, it's moving down towards the center of the earth, I'm going to say it's just moving to its state of buoyance, like it's looking for its equilibrium, and it's displacing because it's in a state of disequilibrium. That's why it moves. Now, if you're going to claim that there's a force doing it, I'm going to say, but we know it's density related. Where's the additional force? Oh, well, it's accelerated mass. No, the accelerated mass isn't the force. It's just a state of disequilibrium relative to the medium it's in that shouldn't be where it is.
Do a quick shout out to Agent Dubsky for hitting the super chat ages and ages ago. Thank you very much indeed for your support. Really appreciate it.
Yeah, I get what you're saying, Anthony. I do get it. It's just, I guess, and I'm not even saying more moving towards the center of the earth. I'm not even, but that phrase wasn't even in what I was describing.
I got your question. Paul, you want us to walk off the ball and find out the way how density is different from the altitude versus locally on the ground. The only way to find that conceptual idea is we have to walk off the ball and not assume that there is a center, which is the whatever they're pre-indicating. Other than the only proof that we have right now is these magnetic ley lines and nodal points. How I perceive to look at it actually is that these ley lines and nodal points in this physical reality is like no different than a rebar and a cement mix creating the shape of whatever building it is. But however, these ley lines are below the dirt, and they do have effect with our electronics, our compasses, and a strong possibility that we're actually why we're stuck here on the ground. So, I mean, just how I see it, like a UN map, like an actual, it's everything's like flattened out, and you see all those grid points, those axes, or degrees. I could see it in that model, and then if I were to actually be on a plane or top of Mount Everest, I could see it. I mean, that our weight or our density should be a lot lighter because we're physically off the landscape of the Earth. That's my opinion, Paul, and I hope that kind of fits that answer fits to your question.
Well, I guess in a way, but I mean, I guess I'm really talking about. I guess direction is a bad word. I guess maybe the better way to describe it would be why would they order themselves? Why do denser objects order themselves in such a manner where the denser things are towards the ground and the lesser denser things, they order themselves in that way? And I'm not implying a force. What's that?
Don't like staying in a state of disequilibrium. The order is ranked by the density value, and it's the desire for them to find equilibrium for whatever reason, because gravity shouldn't be selective over when it finds like its relative state. Gravity should apply always, but it doesn't. It seems to not apply with helium balloons. And also remember as well, Newton's third law. Newton's third law states that for every action, there's an equal and opposite reaction. We always forget about that law when we're talking about the relative density or gravity or whatever, this topic, because every time there is a movement of any kind, there is an equal and opposite re-movement that we never talk about. So that balancing act itself tells you that gravity can't be what's going on, because gravity can't affect just one. It has to affect them both.
And with that, I'm going to say a huge, massive, enormous thank you to all of today's debating panel for making this live debate possible. If you are watching on Nathan Oakley, then stay tuned, as there will be an after show to follow. Also, of course, a massive thank you to all of you in today's live audience for liking, smashing the super chat, commenting, sharing, subscribing, all that good stuff. I've been Nathan Oakley, and I'll see you all in the next video.